So yeah, my name is Matevz Domajnko. I'm the CEO of Verus Digital, which is a spin-off company of renowned Fraunhofer Institute for Computer Graphics in Darmstadt. Probably most of you already heard of Fraunhofer Institute. It's one of the largest institutes for applied research in Europe. There is around 70 institutes in Germany and in Europe, each one focusing on different technologies. So our institute is based in, or it has headquarters in Darmstadt, focusing on computer graphics. And at our department, we are focusing on different 3D scanning technologies. And also the department is called Cultural Heritage Digitization. Before I explain a little bit more about the history and so on, I will show a short video already a little bit explaining some of the main challenges and opportunities for 3D digitization of cultural heritage. And at the end, there is also a short sneak preview already of our newest solution. Please let me know if also the sound works for you.
Imagine a way to make cultural heritage more accessible. A way to digitize hundreds of objects, entire collections, not just in the form of photos and videos, but as an interactive experience.
There are solutions for scanning and reconstructing objects in 3D, but with the existing technologies, the quality of resulting models can be very inconsistent. The scanning and data processing can be very tedious and time-consuming. Also, most systems currently on the market cannot scan certain materials. That's why we came up with a new approach.
Since the start of time, we've been learning from our past in order to improve our future. Why stop now?
CultArm 3D operates almost completely autonomously. Once set up and calibrated at location, it can detect the shape and material of arbitrary objects and adapt to it. It starts capturing multiple photos until it has gathered enough information for the reconstruction process. Our system is user-friendly and delivers high quality and ready-to-use 3D assets, while always ensuring the safety of your objects. There is no need for tedious post-processing anymore, so you can focus on what's important in your work.
Anyone can use it. Basically, you can just place the object on the turntable and the system will do the rest for you.
Okay, but now let's start also with, let's say, a little bit more the history and how everything started. In 2014, let's say 2013, 2014, we identified the growing need for mass digitization or mass 3D scanning of cultural heritage artifacts. And that's when we started developing the so-called CultLab pipeline, which you see it now on the screen. This was a long conveyor belt system, around 8 meters long, and it had already 2 different scanning stations. So the artifacts, the museum artifacts and objects moved along the conveyor belt system, and then at each station it got digitized in fairly quick time. We also tested then this solution at different locations. Also, we shipped it to the US, different locations in Europe, and we try to really see how to make it user-friendly, how to make it really accessible for larger institutions so they can really proceed with mass digitization of cultural heritage. Unfortunately, we saw that it is a little bit more challenging and that there are maybe different priorities than we thought, mostly from, let's say, engineering perspective. So as you can imagine, the system is not super mobile, it's very large. And also there were some safety concerns because the artifacts to move along the conveyor belt system also doesn't give so much, let's say, security feeling. And that's why we changed a little bit the priorities and we started developing, let's say, new system. And the priorities, we changed it in a direction that everyone needs to feel super safe, super comfortable using it. Then the second priority was high quality, highest accuracy of the results, and only then the time. And that's when we started, let's say, with this new project, which we call it CultArm. So cultural heritage, robotic arm, together, CultArm 3D. So this was in 2018. So before we started focusing on the new technology, we also received some awards for the CultLab 3D technology. Probably you already heard also of Europa Nostra award. Also, we got some other technical awards in 2016 to 2018. And then we started focusing on this more, let's say, mobile and more mobile version of the 3D scanning solution. We developed different prototypes and we started testing them at different locations, different museums, cultural heritage institutions, and we were listening really to the users and customers, what they appreciate the most and what needs to be further improved. So this, let's say, pilot phase was running till 2023, where the system was really, and technology was really ready to go out there and to offer it really as, let's say, as a product that can really be safely used by anyone. In this time, we also got some very interesting feedback. Here I will highlight maybe two most interesting and also very positive feedbacks. So the first prototype was installed at Badisches Landesmuseum in Karlsruhe, where they started using the system and they saw that it is so safe and so easy to use that they decided to open the scanner also for the public. So right now you can even register as a visitor, and you can use the system on your own to digitize, together with their curators, digitize some of their artifacts. Another interesting feedback was from one of the largest natural history museums. It's Museum für Naturkunde in Berlin. They have digitization department, I think even for around 10 years, using all kinds of 3D technologies. As soon as they saw in 2022, as soon as they saw our technology, they wanted to have the system as soon as possible because they were so impressed by automation of the process. In all of this time, we of course we were using also different kinds of technologies. We were capturing different kinds of objects in terms of materials, in terms of shapes, different sizes, and we try to, from each of these projects, we try to learn something and improve the technology further. Mostly we were interested in challenging objects like shiny surfaces, very complex geometry of objects, also some transparent objects, movable, and so on. So we really try to test where are the limits of the technology, and we always try to push it a little bit further. So during testing, let's say, all kinds of technologies, we also then identified, let's say, what is the main problem or challenge in this mass 3D digitization and how to find the right solution for it. Probably some of you are already using some 3D scanning technologies. So it is always important that the whole process is correctly planned. For example, that you have the right someone who can handle the objects, but also scanning expert to plan, let's say, the whole process. Then it's very important that, let's say, operator captures all of the details of the object. So it doesn't matter if it's a structured light scanner, laser scanner, photogrammetry, and so on. It's very important that all of the parts, even hidden parts, occlusions, are always captured well. And then all of the data goes into the processing workflow where, let's say, data technician needs to process it. Some of the processes are already automated in general now. And then what you get is many times, let's say, are some results that still need some cleaning. They need to close the holes. Maybe they need to project certain colors and textures. And for this, expertise of a 3D artist are necessary. So overall, we saw that for cultural heritage, the most important thing is consistency of the results so that you can really use it for documentation. And on the other hand, of course, all of this workflow is very, let's say, overwhelming, especially for museums that need to start with digitization, where to get all of these experts, how to get in these workflows. And yeah, that's why we try to really make also our technology as easy as possible to use. So basically, you just need to place the object on the turntable, press a button, and then the system will automatically start capturing all of the details on the surface, while a user operator can already, for example, prepare the next object, have a cup of coffee, or do other things. Everything will be also automatically processed and even post-processed in order to generate, so let's say, ready-to-use 3D assets. This, of course, opens many new opportunities. And on the next slide, we can already see how the technology works. That's one of the prototypes that you can see here on the system. So an operator places the object on the turntable, and then the system in different phases starts capturing, let's say, the shape and size of the object. Now we see in the second phase, the system already detected some more details of the object. Some parts are still missing, and this happens then the system then captures more information in the follow-up phases until it has all the information, not only for precise model in geometry, but also to have color-calibrated results, as you can see it now on the right side. So once you get, let's say, this 3D model, then of course this opens many new opportunities and many new possibilities. What we are focusing on, or what is also our goal, is to establish a new standard, which we call it true 3D digitization, which would mean that every single detail that a human eye, that a person can see on the object, so everything what you can see with the naked eye on the object also needs to be captured on the 3D model. And this means, this is for both, for geometrical details and color details. And only then, when it's captured with this level of quality and it is really consistent across the whole surface of the object, then it can really be used for accurate documentation, and you can also use it for further scientific analysis. On the left side, we see, for example, also some of the potential outputs where also, let's say, some special textures can be generated that, for example, highlight some scratches, some details, or also it can be, it can produce also different kind of color textures for further scientific analysis. Then also this whole workflow, once you have high quality 3D model, also can be already prepared for 3D printing, not only printing in terms of, let's say, geometry, but even color 3D printing. So here, for example, yes, we have a video on the right side where we see one painting. That's just a painting of one local, let's say, artist. And when we look at it, when we look also at the printed replica, basically we don't see a difference, not only in colors, but all the brush strokes, all the details, everything is also reproduced on the painting, on the 3D print, and this is generated completely automatically. So the next step here is, of course, that we create full automatic copying machine, or let's say 3D copying machine. Then very important also for this project, if I move to the virtual and augmented reality experiences, so the models that are, of course, in high quality, they need to be optimized. This also happens automatically, that they are optimized for the use, for example, on the web or virtual reality or augmented reality. This opens, of course, many interesting opportunities because museums can use as part of their exhibitions, can start using also augmented reality in the exhibition space. But also what is interesting, for example, at home in your living room, you can already project and use some of the 3D models directly and experience it in your own environment. Yeah, this elephant that you can see it, of course, it's only augmented reality, and then you can just project it in your space. This technology we packed now into two different products. The first one, we call it CultArm 3D DT10. It's a desktop system which can capture all kinds of objects from, let's say, 3 centimeters up to 1 meter 20. And then the larger one, we call it FT20. It's a floor standing system which can capture objects up to 2 meters 20. The important thing is that no matter what is the size and so on, you can always decide what kind of resolution you want that the system achieves. And then the system will automatically continue capturing the data until it has all of the information for that target resolution, target quality, which can be even below 15 micrometers. And then everything is, as I already mentioned, it's completely automated. And the important thing is exactly this, that we get consistent and reliable results that we can use it further for, or we call it also scientific accuracy results. One of the latest systems, I have here also another video of this large system. It also just grew in the last months. So we are already using larger collaborative robot. And if I show a quick time-lapse video, you can see that it can, if you can place, for example, even a statue, large statue on the turntable, the object can capture it also from the top. And yeah, this is just to mention, that's of course a time-lapse. I think it's 220 times the speed, and it operates very smoothly, very safely. So there are no problems at all. Then I just quickly show a little bit what is coming next, or what we are already, what is already in proof of concept stage. Here we see, for example, a prototype where the system can even capture paintings, for example, directly on the wall. You bring the system, it comes also on the wheels, you bring it next to the wall, and it can capture directly paintings or mosaics or some friezes that are directly part of a wall. Then what we are also now testing is, let's say, module for fixed statues. This is just a simulation. Here you see that the statue is fixed, and then only the robot moves around certain side of the statue, and it also makes sure that it captures all kinds of details. What we also see now on the right side is a little bit already explained how the technology works. So for example, here on the right side, on the bottom, you see already that the system knows at all times exactly which part of the object is perfectly sharp in so-called depth of field, and only those perfectly sharp parts of the images will also be used for the final model, and that's how we can make sure that the quality of the final result is really scientifically accurate. Another interesting part is maybe also additional UV lighting. For example, you can also capture objects with certain narrow bands of multispectral lights. If you add different lighting, you can also then extract more information from the object. That's sometimes important for certain some historic paints, or also for painting statues and so on. Okay, and here at the end, you also see now on the left side some of the results. I don't know how we are with time. If we have time, I can also show maybe some of the most interesting results also directly on our website. But maybe, yeah, Sarah, maybe you can let me know how it is on the time.
Yeah, I think we'll be fine with the time. So maybe you can maybe show those examples.
Maybe what is interesting, so we have, then I can show our scan of the month category. So each month, either with our partners or those museums that already have the system, they also publish, let's say, one interesting object with an interesting story behind it. And then we also put those models online. This is one of the recent one. It's an interesting fossil that was found in this region, where we captured it with all of the details. And then this model was also 3D printed. Here, for example, you can imagine how many details are really visible on the final 3D models. So in the beginning, we saw, let's say, geometrical model, and now also the camera zooms in, where you can also see all of the details also on in colors. Then if I show, yeah, why not? The second one, so this is like an earring from the Indonesian island Java, where many years ago they were known for this, let's say, for crafting small golden jewelry. And this is an earring which is only 3 centimeters large, so we can really see what kind of details the system would capture. So if we imagine that that was 3 centimeters, the whole object is around 3 centimeters. This means that all of these details are below 1 millimeter, and we see that all of the details are perfectly captured, including all of the hidden parts on the inside, so that you get a really complete object or complete surface of the object.